Okay, hi, Assalamualaikum and Salam Sejahtera. I'm Madam Farha binti Amimah here. I am from Group 69. I would like to present open-ended lab for shear force and bending moment. This is my team member of Group 69, and we have here Vignes Varan Vigaya Kumar as a solver, Nur Shakira binti Alias as a strategist, Siti Narisa Nazri as a secretary, and Wahida binti Hashim as a reflector. And Vignes as a Vignes task is to finalize the theory and experiment, and also the procedure, and he also helped uh, to do the introduction and objective of the lab report. And No Shakira binti Alias is a strategist. Her roles is to think, to give the best appropriate way to avoid any mistake and error during the experiment. And she also lists the subtopic to the others members as a guideline to make it all the presentation and also the video and also the lab report smooth, uh, smooth, and everybody can contribute their part. And Siti Narisa as my secretary, uh, she also helped me to organize the team member, remind our team member, and collect the data and compile the result. And last but not least, Wahida binti Hashim as a reflector. She find the relevant reference that suitable for us to use through the online, and she also helped us to interpret the lab report and lab note and do the conclusion and discussion for our group. Next, I would like to explain about introduction of shear force and bending moment. The shear force at any point along the beam is the total forces acting perpendicular to the longitudinal axis up to the point. The bending moment at any point at the beam is equal to the area under the shear force diagram up to that point. And the objective of this experiment is to determine the shear force and bending moment at the particular section, especially focusing on x-axis section, and compare with the theoretical calculation.
Assalamualaikum and hi everyone. My name is Nur Shakira binti Alias and I am from Group 69. Today I would like to present about the shear force and bending moment for the variation of load and variation of load position. First of all, we have to know the apparatus for the test, which is this is the simply supported beam. Clearly stated the support A, B, D and C. The second is digital force display, which is will display the value of the shear force or bending moment at the section XX. Okay, first of all, shear force at variation of load. We have three loads here, which is 100 gram, 200 gram and 300 gram. This mass we will place at the between A and B, B and D and C and D. For the shear force variation of load, first we have the mass of 100 gram between B and D, 140 mm from the B point. After that, we read the value at the digital force display, which is the negative 0.3 Newton. Then we put the 200 gram mass between B and D here, 140 mm from the point B, and we here, which is 0.6 Newton. After that, we change it to the mass of 300 grams. Here, we hang it 140 mm from point B, and the value is 0.9 Newton. Now I would like to present the shear force variation at cut section XX due to variation of load position, which is we hang the 200 gram mass between point A and B here, and we read the value at the digital force display. Secondly, we put the 200 gram mass between the point B and D here, and we read the shear force at section XX at the digital force display. Third, we hang the 200 gram mass between the point D and point C here, and we read the value at the digital force display. Now I would like to present about the bending moment variation at cut section, which is the apparatus have the lever arm to read the bending moment value. First of all, the variation of load, we put the 100 gram at the point of B and D, 140 mm here, and we read the moment. For the bending moment test, we have the bending moment value at the section XX, which is will display at the shear force digital display. Secondly, we put the 200 gram at the same location, 140 mm from point B, and we read the digital force value. Secondly, we put 300 gram between point B and D, 140 mm from B, and we read the value at digital force display. For the experiment 2, bending moment at the variation of load position, which is we put 200 gram at point A, between point A and B, 100 mm from A, and we read the bending moment at the digital force display. Secondly, we put the 200 gram between B and D, 140 mm from B, and we read the bending moment at the digital force display. Secondly, we put the 200 gram at the point D and point C, and we read the bending moment at the digital force value. Thank you.
For shear force due to uniform distributed loading, firstly we need to apply at least 3 same magnitude loads next to another and make sure the distance between each point load is same. Then we will calculate the uniform load by using this equation where the total load divided by the distance. Next, we will calculate the value of shear force at section XX by using this equation. After that, we need to compare the shear force with the measured shear force at section XX for the 3 cases for different places. For bending moment due to uniform distributed loading, firstly, we need to apply many point loads where each of the point loads has the same magnitude and load must apply next to another. Then we will calculate the uniform load by using this equation, which is uniform load equals to total load applied divided by distance. Next, we calculate the bending moment at section XX after obtaining the RB by using this formula. Lastly, we will calculate the bending moment at section XX by using this formula.
For case 1, the load of 300 gram was placed at point A. The load of 170 gram is placed at 80 mm from point C. Repeat step 2. The load 300 gram at point A and the load of 250 gram is placed 80 mm from point C. For case 3, load of 300 gram at point A and the load of 490 gram is placed 40 mm from point C. Thank you.
From the experiment as a conclusion from our group 69, the theoretical value is lower than the actual moment value. The distance of the moment can affect the beam reaction point as shown in the figure. Supervision value is caused by two or more reactions in along the beam in the sum load to respond that would have caused each reaction to stimulate individually. As a conclusion from our group, the experiment bending moment which caused a beam to bend, the value of the shear force and bending moment can be used to draw the diagram of shear force diagram and also the bending moment diagram. And from the diagram, we can derive the sagging position and also the hogging position on the beam through the drawing. Thank you for listening and thank you, Doctor. Assalamualaikum.